Welcome to Continued Pre-Training. This lesson is part of Module 06, Advanced Topics. Let's get started. Let's now look at Lesson 6.4, Continued Pre-Training, Domain Adaptation. Here we can see the domain adaptation flow. Let's now look at Overview. Here we can see the data mixture ratios. Transform your general purpose model into a domain expert through continued pre-training, CPT. Learn to specialize models for medical, legal, code, or scientific domains while avoiding catastrophic forgetting. Duration, 90 minutes. Difficulty, advanced. Let's now look at learning objectives. Here we can see the catastrophic forgetting. By the end of this lesson, you will understand continued pre-training versus fine-tuning, create domain-specific pre-training data, prevent catastrophic forgetting, train domain-adapted models, evaluate domain expertise, achieve plus 20-40% domain performance. Let's now look at pre-training versus fine-tuning versus continued pre-training. Here we can see the curriculum learning. Let's now look at understanding the differences. Here we can see the domain data mixing. Here's the bash code for this section, starting with data, massive text, trillions of tokens. Here's the bash code for this section, starting with data, instruction response pairs, 100, 1000 examples. 3. Continued pre-training. This lesson. Here's the bash code for this section, starting with data, domain-specific text, millions, billions of tokens. Let's now look at when to use each. Here we can see the perplexity improvement curve. Goal, use, example. Yourself, general assistant. Fine-tuning, ChatGPT-like bot. Domain expert, CPT, then fine-tune, medical diagnosis, AI. Task specialist, fine-tuning only, JSON extractor. New language, CPT, then fine-tune, rare language model. Key insight, CPT teaches knowledge, fine-tuning teaches behavior. Let's now look at creating domain pre-training data. Here we can see the CPT evaluation suite. Let's now look at data requirements. Requirement, CPT, fine-tuning, SIG, C. Amount, 10M to 10B tokens, 10K, 100K tokens. Format, raw text, instruction pairs. Quality, domain relevant, task relevant. Diversity, high, medium, for CPT on 2x Tesla. P40, target 10 100 million tokens, realistic in 2-10 hours. Let's now look at example 1, medical domain. Data sources, PubMed abstracts, medical textbooks, clinical notes, anonymized. Drug databases, medical Q&A sites. Collecting medical data. PubMed API search for PMEDs. Fetch abstracts. Pass XML. Simplified, use xml.ettree in practice. Extract abstracts, basic passing. Extract abstract text. Let's now look at example 2, code domain. Data sources, GitHub repositories, Stack Overflow posts, documentation, code tutorials. Collecting code data. Use existing code datasets. Take first 50K examples. Save. Let's now look at example 3, legal domain. Data sources, court cases, legal documents, law reviews, statutes using existing datasets. Load legal dataset, process save. Let's now look at preventing catastrophic forgetting. Let's now look at the problem, catastrophic forgetting. Model forgets general knowledge when learning domain knowledge. Example, before CPT, Paris is the capital of France. After CPT, medical, Paris is the capital of France, forgot. After CPT, medical, myocardial infarction is learned, not good, need domain knowledge and general knowledge. Let's now look at solution 1, data mixing. Load domain data, medical, load general data, Wikitext, C4, etc. Mix, 50% domain plus, 50% general, adjust ratio, combine save. Recommended ratios, heavy specialization, 70% domain, 30% general. Balanced, 50% domain, 50% general. Light specialization, 30% domain, 70% general. Let's now look at solution 2, lower learning rate. Use much lower LR than initial pre-training. Initial pre-training by Meta, LR JAR 3A4. Fine-tuning, what you do, LR JAR 2E4. Continued pre-training, LR JAR 5E5 1E4. Lower. Why? Preserve existing knowledge, gently add new knowledge. Let's now look at Solution 3, fewer epochs. Here's the Python code for this section, starting with num_train epoch spawn is 1. Sometimes even 0.5 epoch is enough. Monitor general knowledge, test periodically on general Q&A. Let's now look at continued pre-training script. 1. Load base model. Add LoRa, optional but recommended for efficient CPT. 2. Load domain data. Let's now look at evaluating domain adaptation. Let's now look at Test 1, domain knowledge. Generate response. Remove prompt from response. Medical domain questions. Test before CPT. Test after CPT. Expected improvement. More detailed, accurate domain answers. Let's now look at Test 2, general knowledge. Forgetting check. General knowledge questions. Test on domain adapted model manual verification. Let's now look at evaluation rubric. Here's the bash code for this section, starting with domain adaptation evaluation. Let's now look at complete CPT, fine-tuning pipeline. Let's now look at Stage 1, continued pre-training, domain knowledge. Stage 1, CPT on domain text. Input, raw, medical, legal, jot code text. Output, domain adapted base model. Time, 2 to 6 hours. CPT config. Let's now look at Stage 2, instruction, fine-tuning, behavior. Stage 2, fine-tune on medical instructions. Input, medical Q&A pairs. Output, medical assistant. Time, 20-60 minutes. Load domain adapted model from Stage 1. Fine-tune on instructions like Module 5. Result, expert medical assistant with deep domain knowledge. Let's now look at domain adaptation checklist. Here's the bash code for this section, starting with continued pre-training checklist. Let's now look at key takeaways. 1. CPT teaches knowledge, fine-tuning teaches behavior. 2. Mixed domain plus general data, 50-50 to prevent forgetting. 3. Lower LR, 5E5 to 1E4, then fine-tuning 4. 1 epoch often enough, don't overtrain 5. 2-stage pipeline, CPT, fine-tuning 6. Test general knowledge to detect forgetting 7. Achievable gains, plus 20-40% domain performance. Let's now look at what's next. Domain adaptation mastered. Now learn custom architectures. Continue to Lesson 6.5, Custom Architectures. Let's now look at additional resources. Llama 2 paper, CPT section, Domain Adaptive Pre-Training, Catastrophic Forgetting in Neural Networks, PubMed dataset, The Stack, Code Data. Your model is now a domain expert. Time to customize the architecture. That wraps up continued pre-training. Well done on completing this lesson. See you in the next one.